look yesterday at absolute value graphs. So today we're going to put our primary focus on just the graphs themselves. So the question asks us to graph y equals 3x minus 1. So the first thing I'm going to do is I want to talk about the three methods that we have to actually graph a line. Okay, method number one was find your x and your y intercepts and then plot them. The second way was to actually do a table of values because you only need 2 points. So plug in a value for x and then a value for y and draw your line. And then the third way in which we can do it is the slope-intercept form. So if it's already in slope-intercept form, we'll start with that. Okay, so 0 and negative 1, that's my b value, right? And where does my map tell me to go? Up 3, right? 1, 2, 3, and over to here. So I graph that there. Okay. So my y-intercept is negative 1, correct? What's my x-intercept? What is it?
1/3.
Yeah. I have that, right? Where y is equal to 0, and then solve for x. So it's actually 1/3. Okay? So that guy is important to us because he's going to help us describe the domain of this graph in a minute. All right? So now, I have graphed y equals 3x subtract 1. To do the absolute value now, I take everything from the bottom and I reflect it up. So right there, because that's my negative 1, that, and there's my graph of the absolute value of y equals 3x minus 1. So the y-intercept occurs, you can fill this in your book if you want right now. The y-intercept occurs where the graph crosses the y-axis. The x value of the y-intercept is 1/3. We substitute it in. The y-intercept occurs, actually the y-intercept occurs at 0 and 1 for this graph. And x-intercept occurs at 1/3 and 0. You could complete a table of values if you wanted, or you could graph it just the way I did here. Okay? So the line graphs are fairly straightforward, but there is a part that I didn't mention to you yesterday. And they talk about writing out the equation for this graph in what we call piecewise. This is very difficult for people to understand. So what happens here is this. If I look at, actually I need to start fresh here. I talked about this yesterday. The absolute value of 4 is 4, right? And the absolute value of negative 4 is also 4. That's what we learned yesterday, correct? Because it's your distance from the 0 on your number line. All right. Now, this is the part that we didn't do yesterday. That's important that we have to see. If I have this, x plus 1 absolute value is equal to 5. So if I have the absolute value of x plus 1 equals 5, that means then that I have 2 possible solutions for this. Okay, in order to get 5, x plus 1 has to equal 5, or x plus 1 can equal what? Negative 5. Exactly. So I have 2 choices. All right? So therefore, when x is 4, and when x is negative 6. So I have 2 possible solutions for that, right? Does everybody understand that? So, because in order for, excuse me, in order for this right here to equal 5, either this whole thing has to be 5 or negative 5. Agreed? And if it is either one, it'll give me a value there. So far, so good? Yes? Okay, now going back to this graph. There are two graphs here. There are two graphs that we're going to look at that create this. Okay? So graph number 1 is this line right here. And that is the line of y equals 3x minus 1. That was our starting line. So far, we okay? The second line we're going to look at is this line right here. That is the graph of negative 3x subtract 1. Okay? Because this is an absolute value here, either I've got the positive 3x minus 1, or I have the negative of 3x minus 1. Is everybody following what I'm saying here? Because I'm going to make this a little bit crazier here right away. Okay? Everybody okay with this? Yeah? Alright, so now they say to you, in order to get this graph, what domain did you use from that guy to get it? Okay? So remember, our graph is this. Right? And this line is this line right here. Well, what part of that line did I use? So I'm going to make this a little bit easier for you. I'm going to do this part. So y equals. I just want to see how they write it here. Three x subtract 1. What part of that graph did I use? X was greater than or equal to 1/3. So starting here, on this line right here, I only used that part of that graph, correct? So what about for, what part of that graph did I use? What part of this line did I use? Here and that line, correct? So sorry?
And the y is just like everything.
Y, oh sorry, I should put squiggly there. Y is just the equation for these two equations. Okay? So for y equals 3x subtract 1, that line, I only used from here to the right of it. And for this line, I only used from here to the left of it. This is what we call piecewise function. So what we're doing is we're taking a piece from two separate graphs and creating a new graph. Okay? Now, we do very little with this beyond this point. We do a little bit in this class, but not much. So we're not going to focus a lot on it, but you do need to know how it works. Okay? So I'll come back to that in a second, all right?
Just a question.
Okay, go ahead.
The original line, like always get the including, like x.
It doesn't matter.
Doesn't matter.
Just make one of them included. Yes, that's a good question. You can have either or including. Yeah. Okay. All right. So let's see. Let's have a look at this next one now, which is an x squared graph. Consider the absolute value function of y equals x squared minus 3x subtract 4. All right. Now, determine the y-intercept. You substitute 0 in, so you get 0 and negative 4. Determine the x-intercept. You have to factor. Maybe that's the best way we can do this question. Okay, I'm going to do it the way the book sets it up. All right, so I've got this x squared minus 3x subtract 4, right? So the first thing I want to do, now I'm going to do this different. And the reason I'm going to do it different is because when you get into grade 12, we're going to graph the original first and then take the absolute value. So I'm going to ignore the absolute value for a second, and I'm just going to graph this guy. All right? And we have spent loads of time graphing that this year. Okay? We use different methods. Method number 1, get it into vertex form. Method number 2, get the roots of this. Method number 3 would be to find your intercepts. Okay? So the first thing I'm going to do is let's find my intercept. So when x is equal to 0, my y-intercept is what? Put 0 in for x, what do we get? -4. Good. Okay? Now I put 0 in for y. What are my y-intercepts? They're my x-intercepts. Factor it. Factor it.
X and -4
X minus 4, x plus 1. X is equal to 4 and -1. Those are my x-intercepts. Agreed? Yeah? So I have my y-intercept and I have my x-intercepts. Now, if I were to graph this, okay, my x-intercepts, 1, 2, 3, and 4. One is right there. The other one is right here. My y-intercept is 0 and -4, which is down here. That still doesn't really help me. So, thinking back to when we did quadratic equations, and we used the root method, I want to find my vertex. Okay? How do I get the x value of the vertex? Yeah, I find the middle of the roots. Right? So what's the middle between 4 and -1? What is it? What do you think it was? Yeah, that's right. So it's 1.5, which is right here, right? Okay, but we need to find the y value of that now. So substitute 1.5 in here. Get your calculators if you can't do that in your head. Put 1.5 in for x and solve for y. You do it? What is it? Minus 6 point what?
2.
Okay, start contributing here on. Alright, so down here, right there. Okay, so far? So now, there's my graph. Okay, now you can use your calculators for this, to do it, or your Desmos program. You can start with this. Alright, now, this is the graph of y equals x squared minus 3x subtract 4. So how do I take the absolute value of that? What did I do yesterday? Liam, what did I do yesterday? Yeah.
Wow. Go over from 0.
Pardon me?
It just, however many places it was over from 0.
No, but when I graphed it yesterday, I did something to the graph so that would show that it was the absolute value. What did I do? I did. Exactly. Very good. Okay. 1, 2, 3, 4, right there, and then 6.25. So my new graph then is this. There's the absolute value of it. Okay, I reflect it over the x-axis because I don't have any y values that are negative. They all become positive, correct? Now, we're going to piecewise this guy together. So, to do that, okay? So the positive graph was the blue. What was the part of the blue that I used for my green graph?
Like the two top.
Yeah, okay, so I used the domain to describe that. So what's that value right there? -1. So am I using greater than -1 or less than -1? Less than. So I've got x is less than or equal to -1. And, awesome, x is greater than or equal to 4. Just like that. Okay? So for this graph, what did I use? Well, this graph is that guy. So what part of that guy did I use? Between -1 and 4. -1 less than or equal to, oops, I don't put the equals because I've already done that. -1 less than x less than 4. And that's it. Okay? You don't have to do anything miraculous here. All I do is I put this down as a positive, and then I just put brackets around and put a negative in front. And you got it. And it works every time. Doesn't matter what graph we're talking about, it works every time. Okay, so far? Any questions about that? They only give you the 2 examples for this. Any questions? Okay, so to graph, to go back to this, to graph this guy, all right, use your technology if you want. Use your technology today. You need at least the vertex, all the intercepts, and then graph it. Now you could graph this straight onto it. You could graph with absolute value on those programs, but I don't want you to do that yet. I want you to graph the original and flip it, okay? Just to get used to it. Because when you do get into grade 12 and you do absolute value in grade 12, you don't have the calculator. Okay? Any questions? All right. 7-1 and 7-2. Let's have that for Monday.